Two workers burst out laughing as she muscles the first tire toward the trailer. The loader carries some of the weight, but the massive tire refuses to line up. But one tire is only the beginning. Behind it sit 21 more tires from the mine, and now every one of them waits for its turn. Moving them was the first problem. A loader could set only 2 or 3 giant tires on the trailer before the load was full, so she made the same run again and again. Each trip meant more fuel, more equipment time, and another section of the day spent moving something she still had no proof would be useful. The tires themselves had cost her almost nothing. Getting 22 of them home was another matter. The mine had rejected them, but they were not bald or torn apart. Deep tread was still visible, and the thick rubber showed no obvious damage. But on a haul truck carrying hundreds of tons, the mine could not wait until a tire looked worn out. Once it fell below the mine's safety standard, it came off the truck and joined the reject pile. Eventually, all 22 were left scattered across an open pasture. For days, nothing happened. Then the sky broke, and the storm hit. When she returned, the pasture was already drying. But one tire was still holding the storm. She stepped closer. Several inches of rainwater were trapped deep inside its lower sidewall. No liner, no steel tank, no system designed to catch a single drop. The tire had done it alone. She looked across the massive cavity. This was no longer just a rejected tire. It was holding water, and that changed everything. Now came the real test. Turn it into a working stock tank and prove cattle could depend on it every single day. With one tire pulled onto the work pad, the experiment finally became real. She cut away the upper sidewall, opening the center into a deep basin, then scrubbed the inside clean. Years of mine dust, dirt, and residue had to come out before she could even think about putting water in it. From the outside, though, it still looked exactly like what the workers had laughed at. One enormous mining tire, lying flat on the ground. Holding a few inches of rainwater for several days was one thing. Holding hundreds of gallons every day, through heat, cattle, and constant refilling, was something else. She prepared a level base, while the well contractor brought the water line through the center. Then they poured the concrete floor and worked it tightly beneath the inner bead, pressing it into the point where the rubber and the new bottom had to meet without leaving a path for water to escape. Once the concrete had cured, the tire was moved to the test point. She opened the line. Water rushed in, spreading across the new floor before slowly climbing the thick rubber wall. For the first few minutes, everything looked right. The level rose steadily, higher than the rainwater had ever reached. Then something changed. The ground beneath one edge began to darken. At first it was only a damp line. Then the patch widened and crept farther into the dry soil. Inside the tire, the water line slowed. Then it stopped climbing altogether. She shut the supply off. Somewhere beneath several thousand pounds of rubber and fresh concrete, water was finding a way out. The tire had held rainwater on its own, but the first tank she'd deliberately built from one could not hold a full load. Now she had to find out whether the idea itself was wrong, or whether one small part of the build had failed. She drained the tank and worked her way around the base until she found the problem. Beneath one section of the inner bead, the concrete had never packed tightly enough against the rubber. A narrow gap was giving the water a path out every time the level rose high enough. The tire wasn't the problem. One section of the seal was. They opened that area back up, cleaned out the loose material, and packed fresh concrete firmly beneath the bead until the gap was gone. Then they left it alone long enough for the repair to cure before trying again. On the second fill, the water climbed back toward the same level where it had stalled before. She watched the edge of the tire. Nothing appeared. The water kept rising. No dark lines spread into the soil. No wet patch formed beneath the rubber. When the tank finally reached full level, the ground around it was still dry. This time, it held. The prototype had answered one question, but so far, it had only survived on her own property, with no cattle pushing against it, and no ranch depending on it for water. The same well contractor who had helped connect the prototype soon found himself at another cattle property dealing with exactly that kind of dependence. An old steel stock tank at the established watering point had rusted through near the bottom. Water was leaking away faster than the rancher wanted to keep repairing it, and the surrounding ground was already turning soft and muddy. The contractor had just watched a discarded mining tire hold a full load without moving. Now he was standing beside a conventional tank that was failing at the one place the cattle expected water every day. A few days later, the old steel tank was lifted out. The giant tire tank arrived behind it and was lowered onto the same prepared watering point. They eased it into position over the existing supply line until the center connection lined up where it needed to. Beyond the fence, cattle were already gathering. Making the tire hold water had been the first test. Now it had to survive the animals that would use it every day. Filled and connected, the tire tank now sat exactly where the old steel one had been. The cattle came to the same watering point they already knew, lowered their heads, and drank. At first, that was all anyone needed to see. Several animals leaned against the thick rubber rim while they drank, pushing their weight into it the way cattle do around any working water point. The giant tire stayed planted. It did not slide, rock, or shift under them. For a while, the first real ranch test looked almost too easy. Then one steer began paying attention to the center. The valve and fittings sat exposed above the water line, and the steer kept returning to that same spot, rubbing his head against the metal, pushing at it, then leaning in again. The tire barely reacted. The smaller hardware taking that repeated contact was another matter. After enough pressure, the valve assembly moved just far enough out of position to stop working correctly. Nothing dramatic snapped in half. There was no sudden flood. The tank simply stopped refilling the way it should. The cattle kept drinking. Without enough fresh water coming back in, the level slowly dropped lower with every visit. What had looked full and dependable began sitting farther below the rim, until it was obvious the problem was no longer normal use. She checked the tire first. Nothing had moved. Nothing had cracked. The tread and sidewall were still exactly where they had been when the tank went in. Then she checked the center hardware. The valve had been pushed out of position, and the fittings around it showed the damage from repeated contact. A few inches of bent hardware had managed to disable something made from thousands of pounds of mining rubber. The tire had survived the cattle. The plumbing hadn't. And until the vulnerable parts could be kept out of their reach, the design still wasn't finished. Back at the work pad, she wasn't rebuilding the tank. She was protecting the parts the cattle had exposed. The supply line went underground instead of running across the surface, and the valve was moved behind a simple steel guard fixed around the center plumbing. A steer could still lean into the tire or rub along the rim, but it could no longer put its weight directly onto the fittings that controlled the water. Then they took the corrected setup back to Rancher No. 1's watering point. The cattle returned to the same habits almost immediately. They leaned against the thick rubber, pushed around the center, and crowded the tank the same way they had before. This time, nothing moved. The guard held. The valve stayed in position. Fresh water kept replacing what the cattle drank, even under the same kind of pressure that had knocked the first version out of service. That mattered to the well contractor. He had seen the prototype leak. He had seen the first ranch version fail. Now he had watched the corrected design survive the exact problem that had exposed it. For the first time, he had something he could recommend without guessing. His next recommendation took one of the remaining tires to a very different place. The watering point sat deep in a dry pasture, well beyond where the loaded trailer could safely travel. They unloaded the giant tire at the edge of the accessible ground, wrapped a heavy chain around it, and used a ranch tractor to pull it slowly across the final stretch. The tire rolled and dragged through open range until they reached the water point, where it was eased into position and connected. There was no new leak to chase and no second valve failure to solve. This time, the challenge was simply getting a proven design into a place where a normal tank was harder to deliver. And while that installation was going in, the pile back at her storage pasture was changing. What had once looked like an absurd stack of 22 giant tires now had open ground showing between the few that remained. The question had changed again. It was no longer whether the tanks worked. It was how many tires she had left. By then, the tanks were no longer showing up at just one ranch. At another busy cattle water point, a larger herd was already using one every day. The ground around it was worn down from constant traffic, and several animals could drink at the same time without moving the massive tire beneath them. Different ranch, different herd, same rejected mining tire doing a job it had never been built for. Back at her storage pasture, the change was even easier to see. The pile that had once filled the field was almost gone. Only one of the original 22 remained. It stood by itself on open ground where rows of giant tires had once been stacked behind it. When the loader arrived, there was no experiment left to make with this one. The design was already proven. The tire was lifted onto the trailer and sent toward another working water point. Then the truck disappeared down the road. For the first time since the mine deliveries began, the pasture was empty. No tire pile, no spare units waiting. The first 22 were gone, so she went back to the same mine yard where the whole thing had started. Another inspection cycle had already pulled a fresh group of haul truck tires from service. Just like the first batch, they still carried deep tread and thousands of pounds of usable rubber. They simply no longer met the standard required beneath a loaded mining truck. The difference this time was not the tires. It was what happened around them. No one stood back while she struggled to move the first one. The loader was already there. Its fork slipped beneath a fresh reject and lifted it toward her trailer. Then another followed. Then another. The same yard that had once been waiting for those tires to leave, as scrap was now setting the next batch aside for her. The first 22 hadn't been enough.